Butterflies.
I'm Yadi Osuna.
I'm Reagent.
And I'm Karina Clemente.
Hey guys, today I'm going to be showing you how to do a limiting reagent problem using this question right here. So it says if 175 grams of molten iron 3 oxide reacts with 37 grams of 0.5 grams of aluminum, what is the mass of iron produced? So we're going to be using this equation right here, and we have to balance it out first. So we have 2 Fe right here, 3 oxygens, 1 aluminum, 1 Fe, 2 aluminum, and 3 oxygens. So we have 3 oxygens on both sides, and we need 1 aluminum on this side, so we're going to put a 2 right here, and we need 1 more iron on this side, so we're going to put a 2 in front of the Fe. So now our new equation will look like this. So now, So now we're going to have to figure out how much iron is produced. So we know that these 2 equations are producing iron. So what we have to do is figure out the molar mass for each, so we have to do calculations for each of them. So in order to get the molar mass, the first thing you have to do is calculate the both molar weights for iron and oxygen. So iron is 55.85, and you have to times that by 2 because there's 2, and oxygen is 16 times 3. This is 102, or 2 point, oh, it's 101.7, and this is 48, so then that will equal 115, so the whole mass, the molar mass for Fe2O3 is 159. 159.7. So then now we have to do is find the molar mass of the molar weight. So aluminum is about 26.98, I believe. Alright, so it's 26.8 times 2, which is 53.96. So 2Al equals 53.96. So now that we have the weight for both, do it. Okay. So now we have to figure out the molar mass first of Fe2O3. So we will write it Fe2O3. So it gives you the iron, it gives you the grams for iron. So it'll be 175 grams of Fe2O3, and then you will have to multiply that by the molar weight. So then it would be 1 mole of Fe2O3 over 159.7 Fe2O3. Then now we would have to times that by the number of iron that is right here. So then it would be 2 moles of Fe over 1 mole of Fe2O3. So that's telling us that 2 moles, 1 mole of Fe2O3 produces 2 moles of Fe. Okay, so now that we have this, now you'll have to multiply by just the molar weight of iron, which is 55.85 of Fe over 1 mole of Fe. So 1 mole of Fe produces 55.85 of Fe. So now then you have to cross these out, cross out all your equations. So then now you will divide by these and then multiply 2 and 55.85. And 125 divided by 159.7 times 2 times 55.85, which is 122.40 grams of Fe. And we're going to do the same type of problem with aluminum. So we have 37.5 grams of Al as it gave us. Then you multiply that by 1 mole of Al of how much the weight is, which is 26.98, times the 2 mole of Fe over 2 mole of Al. And the reason why we're doing this is went to Fe because we're trying to find how much iron is being produced. So now we have 2 Fe and then 2 Al. So then you would have to multiply that by the weight of iron, which is this, which is 55.85 of Fe and 1 mole of Fe, because that's what we're trying to see how much is going to be produced. So then you cross these out. So cross these out. So now we have to divide 37.5 divided by 26.98 times 1 times 55.85, which will give us 77.62 or 77.6. So then now we have to find out which is the limiting reagent, and which will be this because it's the least number, and this is how much iron that will be produced. 77.62 grams of iron. So this is how you do the limiting reagent problem. So I hope this helped, and thank you for watching.